Padhai Karlo JEE preparation channel. Pachumikilik practice more problems on this exact topic on our Padhai Karlo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is symmetric functions of roots, and how to evaluate them without solving the equation. Let's begin. A symmetric function or the roots of an equation is genuinely any expression built from those roots that stays completely unchanged if you swap the roots around in any order. Alpha plus beta plus gamma is genuinely symmetric, since permuting alpha, beta, and gamma in any way leaves the sum exactly the same. A symmetric function or the root is genuinely any in expression that stays completely unchanged if you swap that around it plus beta plus gamma c, since permuting alpha, beta alpha, beta way leaves the sum exactly the same, and alpha beta plus pa plus p more shamil. Here p acting muk Philadelphia Foj filash karo, Philadelphia in one sign changing the actual value. The genuinely powerful fact is that every symmetric function or the roots can always be expressed purely in terms of the coefficients of the original equation, through the elementary symmetric functions, the sum of roots, the sum of products taken two at a time, and so on, without ever needing to root values themselves. More complicated symmetric expressions are genuinely built up from the basic sum and product relationships using standard algebraic identities. For a quadratic with roots alpha and beta, the identity alpha plus beta squared equals alpha plus beta, all squared, minus 2 alpha beta, genuinely lets you evaluate the sum of squares directly from the sum and product alone. Similarly, alpha q plus beta kj genuinely equals alpha plus beta, minus 3 alpha beta times plus beta, another standard identity built the same way. More complicated symmetric expressions are genuinely built up from the basic sum and product relationships using standard algebraic identities. For a quadratic with roots alpha and beta, the identity alpha squared plus beta squared equals alpha plus beta, all squared, minus 2 alpha beta, genuinely lets you evaluate the sum of squares directly from the sum and product alone. Similarly, alpha q plus beta genuinely equals alpha plus beta, q beta times alpha plus another identity built it the same way. Even expressions like 1 over alpha plus 1 over beta genuinely simplify directly to alpha plus beta over alpha beta, again using only the two non-symmetric building blocks. This systematic approach of reducing any symmetric expression down to sum and product genuinely works for virtually any such expression you'll encounter. The single most frequently tested JEE skill here is genuinely recognizing that a given expression is symmetric. Before attempting this technique, always check first whether swapping the roots leaves the expression's value unchanged. If you solve it entirely through sum and product, without ever needing the individual roots, saving significant time and avoiding messy square roots or complex numbers. A frequently tested trap involves genuinely being given an expression that looks symmetric at first glance, but actually isn't, like alpha squared beta plus alpha beta squared. This expression is in fact symmetric, since it factors as alpha beta times alpha plus beta, and both factors are individually symmetric. So it's always genuinely worth trying to factor an expression first, to reveal its uneven underlying symmetric structure even when it's not immediately obvious. Also remember, this same systematic technique extends naturally to cubic and higher degree equations, using their own respective sum and product relationships. Let's recap. A symmetric function or the roots stays unchanged under any permutation of those roots, and every such function can be x through the sum and product of roots, using standard identities like alpha squared plus beta squared equals the sum squared minus twice the product. Always check whether an expression is symmetric first, factoring where needed to reveal hidden symmetry, and this lets you evaluate complicated root expressions without ever solving the original equation. Here Clois thermal unit SHERIGADA2 Arafilla filled technique is one of the most time-saving tools across the entire algebra syllabus. Here Clois thermal P Sahising Paschimi Afriki Rendine Leone. Keep the sum and product reduction technique sharp. It's one of the fastest time savers across the entire algebra syllabus. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.